Okay, this is our test review for Friday. The last video we discussed factoring with lead values not equal to 1. In this case it's a 5. The way we need to do this is we need to take the 5 and the 10, multiply them together. So we have 5 times 10, which equals 50. And then we need to find factors of 50 that add to 27. In this case it's 25 and 2. So I'm going to rewrite this as 5x squared plus 25x plus 2x plus 10. And then I just go through the normal factor by grouping steps. Okay. Here I'll factor out of 5x. I'll be left with x plus 5. I need to make 2x plus 10 look like x plus 5, so I'm going to divide out of 2. And I'll be left with x plus 5 here. So my answer will be 5x plus 2 times x plus 5. Going on to the next one. Again, the first step, in order to get to 4 terms, I need to multiply 2 times 12. 2 times 12 is equal to 24. Factors of 24 that add to 10 are 6 and 4. So I'll have 2x squared plus 6x plus 4x plus 12. Right? Now, again, pair them up, factor using the GCF. Out of this first pair, 2x squared plus 6x, GCF is 2x, because I can divide out a 2 from 2 and 6, and an x from x and x. And I'll be left with x plus 3. Now I need to make 4x plus 12 look like x plus 3. I can do that by dividing out of 4, so my GCF will be a 4. I'll be left with x plus 3. Now to end in factored form with the two factors, one of my factors will be the x plus 3 that is presented in both sets of terms, and the other factor is what's left over, the 2x plus 4. And you're simply done. Now, for numbers 3 and 4, these are not a difference of squares, right? Because there's no subtraction, it's an addition symbol. Usually when there's only 2 terms and it's an addition symbol, you can't factor by grouping, but you can factor using the GCF, so that's what we're going to do here. In the first term, I can pull out an x, and the second term I can pull out an x to the third. So the largest I can pull out of both is just an x, so the GCF will just have an x. I'll look at the y's. I have y squared and y. This has a single y being multiplied, so I can only pull out a single y for the GCF, and then they both have m's. Same thing, there's one m here, while this m has a 2 for the exponent, so I can pull out a single m for the GCF. Now, after I factor out an x, a y, and an m, the first term, all I'm left with is a y. For the second term, x cubed divided by x is just x squared. Y divided by y cancels, and m squared divided by m, I'm just left with an m. So my answer will be xym times y plus x squared m. Number 4 is the same kind of problem, okay, except we have leading coefficients, which is the 15 and the 9. So the greatest common factor between the coefficients is 15. Between 15 and 9 is 3. I can pull a 3 out from both, and I can't divide it by a greater number without making a decimal for either coefficient. Both terms have an x, so I'm going to pull out an x, and then both terms have up to a y squared, so the GCF will include a y squared. Now this one's a little bit more difficult, so I'm going to show the division step to find the final answer when factoring, which in order to do this, you just write the original and then divide it by the GCF inside the parentheses. Keeps everything equal. 15 divided by 3 is 5. X cancels, y cancels, so I just have a 5. 9 divided by 3 is 3. X cubed divided by x is x squared. Y to the 5th divided by y squared is y to the 3rd, or y cubed, and then you keep your GCF out in front. as the multiplier. And you're done with that. Now number 5 is another factor by grouping problem, but the original term is a 1. Okay? If I wanted to, I can multiply the 1 and the 6 together and get 6. Or because I know this is an easy problem and the leading coefficient is a 1, I can just multiply by the, or I can just find factors of the 6 that can add to 5. Looking at it, I see 2 and 3. So I got x squared plus 2x plus 3x plus 6. And then I'll go through the factor by grouping process. Find the GCF of the first group. It's x. I'm left with the x plus 2. Now in order to get 3x plus 6 to look like x plus 2, I'm going to factor out a 3. And I'll be left with x plus 2. Now, my answer will be x plus 2. And then I'll be left with the other factor of x plus 3. That's it. Now, number 6 is a difference of squares. It's x squared and then 9. 9 just equals 3 squared. That's why it's considered a difference of squares. So I'm just going to take the square root of each. Square root of x squared is x. Square root of 9 is 3. So the first factor is x plus 3. Second factor will be the same thing, but with a minus sign. And you're done. Same thing for number 7. 4x squared minus 49 is a difference of squares. So the square root of 4 is 2. Square root of x squared is x. Square root of 49 is 7. So my factors will be 2x plus 7, 2x minus 7.